At 2:35 in the morning Eastern Time on the 5th of August 2026, a 4-ton cylinder of dead metal hit the moon at 5,400 miles an hour. No atmosphere to slow it down, no parachute, nobody steering. And nobody, anywhere on Earth, actually saw it happen. It was the discarded upper stage of a SpaceX Falcon 9, drifting, unowned, and unpowered for 18 months. But here's the part almost nobody is telling you. The astronomer who called this impact had already been wrong about a SpaceX rocket hitting the moon once before. And the crash that followed left behind something scientists still can't fully explain. To understand how a rocket ends up hitting the moon by accident, you have to go back to a launch that went right. January the 15th, 2025. A single Falcon 9 lifts off carrying 2 lunar landers at once, Firefly Aerospace's Blue Ghost 1, flying for NASA, and a Japanese lander called Resilience. 2 customers, 1 rocket. It's an efficient way to fly, and it worked. Blue Ghost touched down successfully on the 2nd of March. Resilience was less lucky. It crashed on landing that June. But both of them got where they were going. The rocket did its job perfectly. The problem was, what happened to the rocket afterwards? Normally, once a second stage releases its payload, it fires one last time, a short burn to drop itself back into Earth's atmosphere where it burns up harmlessly. Clean disposal. This one couldn't. Pushing both probes out to their release points had consumed nearly all its propellant. There wasn't enough left to come home, and nowhere near enough to escape. So it just stopped. Left in a wide, looping orbit that crossed the moon's path, taking about 26 days to go around. Roughly 4 tons of empty tank and dead engine, 13 meters long, with no transmitter, no control, and no owner watching it. Space junk. Except this piece of junk was in a very unusual neighborhood. Here's where it gets strange. Nobody pushed this rocket toward the moon. It was pushed by light. Sunlight carries momentum. Not much. The pressure of sunlight on a surface is millions of times weaker than the weight of a sheet of paper in your hand. But it never stops. It pushes constantly in one direction forever. And for 18 months, that faint pressure worked on 4 tons of aluminium. And it wasn't alone. Every pass near Earth tugged the orbit slightly. Every pass near the moon tugged it again. Solar activity nudged it further. None of these forces was strong. All of them were relentless. Together, they walked a dead rocket, one tiny correction at a time, onto a collision course. By the summer of 2026, the orbit had stopped being a loop. It had become an arrow. Which brings us back to 2022. Bill Gray is an American astronomer who writes orbital tracking software. He works with publicly available observations, the same data anyone can download. And in early 2022, he spotted something heading for the moon, and identified it as a SpaceX Falcon 9 upper stage left over from a launch back in 2015. The story went everywhere. SpaceX was about to hit the moon. Then Gray checked again and publicly corrected himself. The object wasn't American at all. It was a Chinese Long March 3C booster from the Chang'e 5 T1 mission. China's foreign ministry denied it. They said their rocket had burned up in the atmosphere years earlier. Gray's response was that they'd confused 2 similarly named missions. The object hit the moon on March the 4th, 2022, near Hertzsprung crater. And when NASA finally photographed the site, the argument stopped being about who owned it. NASA's Lunar Reconnaissance Orbiter found the crash site in May of that year, and the crater was wrong. There wasn't one crater, there were 2, overlapping, one about 18 meters across, the other about 16, punched into the surface together like a figure 8. That shouldn't happen. When the Apollo program deliberately crashed its spent upper stages into the moon, every one of them left a single clean crater. A spent rocket is mostly an empty tank. Its weight sits at the engine end. One heavy end means 1 hole. 2 holes means 2 heavy masses at opposite ends of the object. So what was on the other end? A team at the University of Arizona later concluded the booster was almost certainly the Chinese one, and that the most likely explanation for the second crater is an additional payload that was never declared to anyone. There is a piece of hardware sitting on the far side of the moon that no government has ever admitted to launching. Now, 2026. Same astronomer, same method, same publicly available data. Gray identified the drifting Falcon 9 stage and calculated where it was going. This time, NASA's Center for Near-Earth Object Studies, the group that normally watches for asteroids that might threaten Earth, ran the numbers and confirmed it. Not likely, not probable. A 100% chance of impact. NASA and SpaceX tracked it together right up to the end. The target was a barren stretch near Einstein Crater, out on the moon's western limb. Of all the places it could have chosen, it picked the one hardest to see from Earth. So telescopes around the world pointed at the moon and waited. And got nothing. The Dutch satellite tracker Marco Langbroek aimed his instrument at the right patch of surface at the right moment and came away empty-handed. He'd said in advance it was a long shot. The problem is geometry. The impact site was on sunlit ground, at the very edge of the moon's visible face, seen almost edge-on from Earth. Trying to spot a brief flash there is like trying to see a match struck on the far rim of a floodlit stadium, from outside the stadium. There was no fireball. There couldn't be. With no atmosphere and no oxygen, nothing burns. What actually happens is a flash lasting a fraction of a second, and a slow, gray plume of pulverized rock thrown outward in silence. Every telescope missed it. But one instrument in Chile caught something else entirely. The European Southern Observatory's very large telescope, high in the Atacama Desert, was watching, and it detected the chemical fingerprints of sodium and lithium gas in the impact plume, glowing for 5 to 10 minutes after the collision. Here's why that matters. Every element, when it's heated into a gas, emits light at its own exact set of wavelengths. Sodium at one precise color, lithium at another. Split the incoming light apart and those elements show up as bright lines in fixed positions, a barcode you can read. Nobody saw the crash. They read its chemistry instead from 250,000 miles away. Those metals were locked inside the rocket and the lunar soil until the moment of impact. Enough energy was released to vaporize them instantly, and for a few minutes, a dead rocket left a signature hanging above the moon that a telescope in Chile could pick apart. At this point, you might reasonably be asking whether we just damaged the moon. We didn't, and NASA's own comparison is the clearest way to see why. A meteoroid carrying the same energy as this rocket stage hits the moon roughly every 6 days, has done for 4.5 billion years. The moon has no atmosphere to burn anything up, which is exactly why its surface looks the way it does. Every crater you can see is a record of something arriving. The expected new crater is about 18 meters wide and 4 meters deep. On a world with craters hundreds of kilometers across, that's a footprint on a beach. So this wasn't destruction. What it was, though, is something far rarer and genuinely valuable. Natural impacts happen constantly, but scientists never know what hit. Mass, shape, density, speed, angle, all guesswork, reconstructed backwards from the whole. This time, they know everything. The mass, the exact dimensions, what it was made of, precisely when it arrived and how fast. That makes this a calibration event. A known object striking a known surface, producing a crater that can be measured against what the models predicted. It's the closest thing lunar science has had to a controlled experiment since 2009, when NASA deliberately drove a spent stage into the moon's south pole to look for water ice. NASA's Lunar Reconnaissance Orbiter has already photographed this region before the impact. Now it goes back for the after. South Korea's lunar orbiter is looking too. Sometime in the days ahead, we get the before and after pair. And then we find out how well we actually understand what happens when something hits the moon.
There's a number worth sitting with. Human-made material on the lunar surface now exceeds 209 tons. Spent stages, crashed landers, abandoned descent modules, deliberately discarded hardware. 60 years of arriving. Until recently, that barely mattered. Nobody was down there. That's changing. NASA is planning a lunar base. Landers are being built. Astronauts are meant to return before the end of this decade, and China intends to send its own. The astrophysicist Jonathan McDowell put the problem plainly. Things are about to get much busier near the moon. And at that point, an impact throwing dust for hundreds of miles stops being acceptable. To be fair, deliberately crashing a spent stage into the moon is a legitimate disposal method. It's predictable and trackable, and sometimes it's the only option available. SpaceX says this one wasn't deliberate, and that they're working with NASA to prevent a repeat. In a few days, the orbiter sends back the photograph. Subscribe, and we'll look at the whole together.